In this video, I'll be discussing about abstract data type, that is ADT. We'll learn what is ADT, and that I will explain it through an example, that is list example. So we will learn about list ADT. So first, let us learn the term ADT. ADT means abstract data type. So in this, you leave the term abstract. First, we will learn about data type. What does it mean by data type? So a data type is defined as representation of data, and second thing is operations on data. So a data type is defined in two terms. First is how the data is represented, means how you are storing the data. And second thing is what are the operations that you allow on the data. So if I take an example of a integer data type in C, C++ languages, then if we assume that integer data type takes 2 bytes in C, C++, if I assume that, then once I declare any variable of type integer in C, C++, we get memory of 2 bytes. That is 16 bits. So these are 16 bits. So integer type data is stored in 2 bytes together as a single value, as a single data. Now in this, 1 bit is reserved as sign bit to allow both positive as well as negative numbers, and rest of the 15 bits are allowed for storing data, that is any number. This is 1 bit. 1 bit for sign bit, and remaining bits are meant for storing a number. This is how an integer is represented inside the memory in 2 bytes. So this is the representation of integer data type. So as I said that representation of data and the operations of data. Example of an integer I have taken. So integer, this is how it is represented. So this is the first thing we have covered. And what are the operations allowed on integer type data in C, C++ languages? That is, arithmetic operations are allowed on them. That is addition, subtraction, multiplication, division, and modulus. Apart from this, relational operations, that is less than, greater than, and increment decrement operators are allowed, that is plus plus or minus minus, both pre-increment and post-increment. So these are some of the set of operations that are allowed on integer data. So that's all. This is a data type. So if you talk about a data type, any data type in a language, then that data type will have its representations and the set of operations on the data. So when we are learning any programming language, when we learn any data type, we learn mostly about its operation, and sometimes we go into detail and also understand its representation. Now let us see what is abstract. Abstract means hiding internal details. Now if I take this example, integer data type and these operations. For performing these operations, do we really need to know how they are performed in the binary form inside the main memory? No. We are concerned about declaring a variable and using it by performing these operations. So we need not know internal details how these operations are performed. Right? Without knowing them, we can use them. So these things are hidden from us, so we can call them as abstract. Without knowing internal details, we can use it. So internal details are abstract for us. So this is the example of a primitive data type I have taken and explain you meaning of data type and meaning of abstract data type. This is not abstract data type, this is primitive data type. Now the term abstract data type, why it is introduced, what is the meaning of this one? See, this is related to object-oriented programming languages. When the object-oriented programming languages being started used in software development, then using the classes, we can define our own data types that are abstract. That is, without knowing internal details, we can use them. So this term is related to object-oriented programming. So let us take an example of a list and define it as abstract data type. Let us take the example of a list, that is list of elements or collection of elements. So if I say list of elements, I'll take few numbers randomly. So here I have taken the list of elements. Now I can give the indices either starting from 0 or 1. That depends on my requirement. That depends on my definition. So I'll start indices from 0 onwards. So this is 0, 1, 2 and so on. This is a list that is collection of elements. Now this is a list, this is on paper. Now I want this list to be used in my program. Then how I can represent a list? So what are the things that I have to store for representing the list? So the data that is required for storing this list is, first I need space for storing elements. Then the second thing is I need to have some capacity of a list. Then the third thing is inside that capacity, how many elements already I have in a list, that is length of a list or size of a list. So the third thing is size of a list. So for representing this list, I need three things: space for storing the elements, and its capacity, that is maximum capacity, and its size, that is number of elements it is having. So for representation of this one, I have two options. One is I can use array in a program, or I can use linked list. So representation of a list can be done using any of these representation, any of these methods. Then let us look at operations on a list. What are the operations that we perform on a list? Now for the operations, I will write few operations here. Then again, I will explain all of them. So the operations that I may be performing on the list is, in this set of elements or the list of elements, I can add more elements. So the operations that I can perform is add an element, that is X. Or I may want to remove some element from this one. So remove an element. Or I want to search for any particular element. So let us say it is search. I want to search for any element, key element, like this. So on and so on. I'll be discussing all the operations afterwards. Now let me finish abstract data type here. See, this list is an abstract data type. It is having the representation of data and the operations on the data. So when you have two things, data representations and operations on the data together, it becomes a data type. It becomes a data type. Now this I can put together and I can define a class in C++ or in any other object-oriented programming language. Then the question is how you will be storing this list of elements, either array or linked list. Whatever is used, this is going to work perfectly. I'll be performing these set of operations only. Now how the representation is done, I need not bother about it. I need not bother about. When a class is written, I can just create the object of a class and I can use it. So how internally the things are working, I need not worry. That's what it's abstract. So the concept of abstract data type, define the data and the operations on data together and let it be used as data type by hiding all the internal details. So this concept of abstract data type is very common in C++. So I can say that when you write any class in C++, which has the data representation and operations together, it defines an abstract data type. So in our subject data structure, we are going to learn about various data structures like array, linked list, stack, queues, graphs, trees, hash table. All these things we will try to represent them as abstract data type. So I'll be showing you the code for C language as well as I'll be showing you the code for C++. So I'll be showing you how ADT is implemented. We will be defining all these data structures as abstract data types through C++. So while learning other topics, I'll show you how it is working as ADT. Now next, let us look at these operations on a list. I'll just explain you few operations on a list. What is the meaning of these operations? Now I'll explain you the operations on a list. Let us look at the operations one by one. See, first operation, I will call it as add. Add some element. Adding an element, this makes the meaning that I want to add something to the end of a list. Like suppose I want to add 15. So 15 should be added here at an index 7. So add means adding an element to the end of a list. So this is the meaning that we can take. And even this add can also be called as append. Append an element. I'll write in short for an element. So this also means that adding some element at the end of a list. Now next operation, add an element at a given index. So adding an element at a given index. For example, I want to add 20 at index 6. So here I want to insert 20. So it means already the element 12 is there. Then I should shift the element and make a free space for 20. So it means I should move 15 to the next place on index 8 and I should bring 12 here. Then I should insert 20 here. So if you want to insert any element at a given index, then you have to shift the elements. So that's what adding an element at a given index. Adding an element at a given index. This can also be called as insert. Insert at a given index. I'll write in short, that is INDX for index, this element. Adding at a given index, we can also call it as insert. Then next, remove. Removing an element. So which element you want to remove, you must give an index. Suppose I want to remove 20, the one I have inserted just now. So it means this 20 should be removed. When you remove 20, that place will be vacant in a list. So we have to shift the rest of the elements. So 12 should come here and 15 should come here. So I'll be having total 8 elements indexed from 0 to 7. So that's all, removing one element. So rest of the elements are still the part of a list. Removing from given index. Then next operation is set at index a new element. This means changing an element at a given index. Suppose I want to change an element at index 3 to 25. So change this 4 to value 25. So set can also be called as replace, that is replacing an element. Replace at a given index a new element ELE. Then get index. This is just I want to know the element at a given index. Like I want to know what is there at index 5. Index 5, the value is 10. So knowing an element from a given index. Then search for any given key. So searching an element in a list. Like I want to search for an element 9. So yes, it is found here at index 2. The result of search is we get the index. We know the element 9. We want to search for it. So we should know where it is in a list. So it's at index 2. So searching for an element to find its index if it is present in the list. The search is also called as contains key. So we want to know whether this key element is there in the list or not, or the list contains that element or not. Next, you may want to sort the list. So you want to arrange all these elements in some order. That is, you want to make it as a sorted list. So these are the few operations on a list I have shown you. There are other operations also you can perform. That is, you can reverse a list, and when there are more than one list, you can combine them, or you can merge them, or you can split a list. So a lot of other operations you can perform on a list. So as a part of topic, that is ADT, I have taken an example of a list and I have shown you how it is represented and what are the operations. So I have explained you what these operations means. So that's all about ADT. So let us move on to the next topic.